It's Jo Karen Hudson. Today I'm going to work with you on section 2.1, which is exponents, order of operations, and inequalities. For any real number x with b greater than or equal to 0, b to the x is called an exponential expression. The number b is called the base and is being raised to the exponent x. The number x is called the exponent or the power. Example 1, I want to evaluate 3 to the 5th power. 3 to the 5th power is the same as 3 is used as a base 5 times, 3 times 3 times 3 times 3 times 3. And I know that 3 times 3 is 9, times 3 is 27, times 3 is 81, times another 3 is 243. I can check this on the calculator. I want to show you how. I have my calculator out now. 3 raised to the 5th is equal to 243. So it does check. And I'm going to grab that down here so you can take a look at it. Example 2, I want to evaluate 5/10 raised to the 4th power. Now I notice right off the bat that 5/10 will reduce. So let's do that. 5 is 1 times 5 and 10 is 2 times 5. If I cancel out the 5s, this reduces to 1/2, and that will be much smaller to have to raise to the 4th power. 1/2 to the 4th power would mean 1/2 times 1/2 times 1/2 times 1/2. And I know that 1 times 1 is 1, times 1 is 1, times 1 is 1. So in the numerator, I'm going to put a 1. And in the denominator, 2 times 2 is 4, times 2 is 8, times 2 is 16. So I will put 16 in the denominator. Now in example 3, I'm going to evaluate -3 raised to the 2nd power. Now notice this -3 is in parentheses. That means that's the whole base. The -3 is going to be raised to the 2nd power. The -3 is going to be used as a factor twice. So I will have -3 times -3, which is +9. Now the next example looks a whole lot like that, but it has a different answer. So let me show that to you. Example 4 is the opposite of 3 raised to the 2nd power. There are no parentheses here. When there are no parentheses, the exponent only bosses the base. This means the opposite. The base is 3. And I'm using it as a factor twice. 3 times 3 is 9, and the opposite of 9 is -9. So you'll want to look at that very carefully so that you make a mental note of how that works. Rules of order of operations. Step 1. Simplify the expressions inside the grouping symbols. Grouping symbols are parentheses and brackets. If an expression has more than one set of grouping symbols, work from the inside outwards. Step 2, apply all exponents. Step 3, do all the multiplication or division in the order it occurs, working from left to the right. Step 4, do all the addition and subtraction in the order it appears, working from left to the right. You can remember this order using the little slogan, PEMDAS. Please excuse my dear Aunt Sally. The capital letters represent what is to be done. P represents parentheses. E represents exponents. M and D represent multiplication and division. A and S represent addition and subtraction. Now, let's look at a few examples. Simplify each of the following. Our first example, 3 plus 7 minus 2 times 2. We'll want to think about our PEMDAS. We don't have any parentheses or exponent, but there's a multiplication here. So we will want to do that first. So that we will have 3 plus 7 minus 2 times 2, which is 4. Then we have addition and subtraction. We want to work from left to right. 3 plus 7 is 10 minus 4, and 10 minus 4 is equal to 6. Example 2, again we want to remember our PEMDAS. We do have parentheses, so we want to distribute first to get rid of those parentheses. Actually, I don't need to distribute. I think I can just add the 3 and the 4 together. 2 times 3 plus 4, which is 7, plus 5 times 2. And now I'm going to multiply. And then I will have 2 times 7, which is 14, plus 10, which is equal to 24. You would have gotten the same answer if you had a distributed here, but of course, since you can add 3 and 4, that would be the easiest way to do it. Example 3, we need to again remember our PEMDAS. We have division and multiplication. They're of equal importance. We have multiplication. So I want to do that in the order that it occurs from left to right. 4 divided by 2 is 2. This is 2. And then the 2 times the 3 gives us 6. Plus 6 times 5 gives us 30. And then when we add 6 plus 30, we will get 36. Example 4. I will want to take care of this 3 squared first. Its exponents. Please excuse my dear Aunt Sally. We know that 3 squared is 3 times 3, which is 9. 3 squared is equal to 9. So I'm going to fill that in. 3 times 2 plus 12 minus 9 plus 5. And then I'm going to want to simplify what's in these parentheses. And I will have 3 times 2 plus 12 minus 9, which is 3, plus 5. And then I will want to simplify within the brackets. I will have 3 times 2 plus 3, which is 5, plus 5. And then I have to multiply before I add. 3 times 5 is 15, and 15 plus 5 is equal to 20. So 20 is the solution to example 4. In example 5, I will want to work the numerator and the denominator separately. 8 times 3 plus 5 times 2. Starting with the numerator, I will need to multiply before I add, so that in the numerator I will have 6 plus 8 times 4, which is 32. In the denominator, I will need to multiply here within the parenthesis. It would give me 8 times 3 plus 10. Then I will have 6 plus 32 is 38, times 8, 3 plus 10 is 13. And then I will have 38 over 104, which will reduce. 2 times 19 is 38, and 2 times 52 is 104. If I cancel out the 2's, I will have 19 over 52. I do want to remind you about reducing on the calculator. Let me get my calculator. If I want to reduce 38 divided by 104, 38 divided by 104, I will get a decimal first. Math, enter, we'll take it back to a fraction. It is the fraction 19 over 52. That is what I wanted. Let me drag it down right underneath it so that you can see that they do match. Inequalities compare two quantities. Now, let's write some inequalities in words. The first inequality, if I want to write it in words, 3 is not equal to 5, would be written 3 is not equal to 5. This is the symbol for is not equal to. The second inequality, 7 is less than 8. 7 is less than 8. Notice that the inequality, the little end, always points toward the littler number. The third inequality, 7 is less than or equal to 8. 7 is less than or equal to 8. 25 is greater than 5. 25 is greater than 5. Notice the inequality is still pointing toward the smaller number. 25 is greater than or equal to 5. 25 is greater than or equal to 5. The little equal mark down here, the little line down here stands for or equal to. Change the direction of the inequality sign without changing the meaning of the statement. 7 is less than 8. 7 is less than 8 is the same as, okay, we're going to reverse the numbers. We'll put 8 on the left side and 7. If I reverse the numbers, I need to reverse the symbol. Notice in the first inequality, the little n was pointing toward the little number 7. In the second inequality, it's pointing toward the number 7. I copied an equal sign down there, and I did not need it. Okay. 25 is greater than or equal to 5 is the same as. I'm going to reverse the numbers, put the 5 on the left and the 25 on the right. If I reverse the numbers, I will need to reverse the inequality symbol. Less than or equal to. I do need an equal to there. Notice that it pointed toward the smaller number in the beginning, and it still points toward the smaller number at the end. This is Jo Karen Hudson. We have completed section 2.1. You will need to do the homework on section 2.1, the quiz on section 2.1. Thank you for listening, and have a wonderful day.